Alright, in this video we're going to look at being able to simplify radicals, and also look at being able to add and subtract radicals as well. So first thing we want to do is look at being able to simplify a radical. And the examples I'm going to go over: the radicand. Again, what's underneath the radical is what we call the radicand. Will just be constants, just numbers, no variables. So when you're looking at a square root, there's really two ways that you can approach this. Now, obviously, if you had the square root of 9, that would just be 3, right? It would simplify down to a whole number. And again, the square root of 9 is 3 because 3 squared, or 3 times 3 is 9. Now, if you have something like this example here, the square root of 75, it does not simplify to a whole number. All right, we want to give the exact answer. If we plug this in our calculator, it will be a decimal that is rounded, because square roots that don't simplify to be a whole number are what we call irrational numbers. They're decimals that are not repeating and never end. All right, so the first school of thought here is we're going to try to factor this number 75, and I won't basically, are there any factors of 75 that we know the square root of, right? And I always try to do, I try to find the largest one up front, because then there's less steps. So I try to think of the largest factor of 75 that we know the square root of. So let's think about perfect squares that are smaller than 75. But let's start with the largest and kind of work our way down. So 9 squared is 81, so that's too large. 8 squared is 64. 64 is not a factor of 75. 7 squared is 49. 49 is not a factor of 75. 6 squared is 36, which is not a factor of 75. And 5 squared is 25. Now, 25 is a factor of 75, right? So we want to factor or write down 75 as 25 times 3. Right? And the reason we want to do this is because we know what the square root of the factor 25 is, right? So we can simplify this, right? Again, it's got to be factored. It's got to be written down as multiplication in order to do this. We can't say, well, 75 is 25 plus 50, and we know the square root of 25 and simplify that way, because that's written as a sum. It's got to be multiplication, right? So 25 times 3 is 75, and the square root of 25 is 5. So we can simplify this, and so square root of 25 is 5, so we put that directly in front of the radical, right? It's being multiplied to the radical, and again, we still have the 3 underneath the radical here, right? And you always want to check to make sure that, is as simplified as we can make it. And that's why I start with the largest number factors, the largest perfect squares, and kind of work my way down, because that assures me that I'm going to have the simplification process in just one step. Right, but you see 3 is prime, and we can't simplify the square root of 3 any farther. Now, the other way you can do this is, instead of trying to get a factor the square root of, we're going to see if we can get 2 of the same factor. So, if you would prefer to do it this way, you certainly can do that. And so what I'm going to do is I'm going to start by just, not even worried about which factors are perfect squares, but looking at 75 and just write down factors of it. And again, we're going to try to get the prime factorization of 75. And so looking at 75, I can, there's 2 ways you can go about this: 25 times 3, or you could do 5 times 15, right? Well, if I write down 25 times 3, well, then I want to look at the 2 factors, 25 and 3. Well, 25 I can write as 5 times 5, right? 3 is prime, so I can't break it down any farther. And so now you see here we've got the prime factorization of 75 is 5 times 5 times 5. Now, since we have 2 of the same factor, right, and again with the square root, the index is understood to be a 2, which you won't see. And again, the index is located in the little corner right here. With square roots, since it's the most common, we don't write down the index, but it's understood to be a 2. All right, so with the square root, you're looking for 2 of the same factor. And so you can see here we've got 2 of the same factor, 5. And so the square root of 5 times 5 would just be 5. Right? And so that's the other way you can do it. So you can either try to find the largest factor of that number that you know the square root of, or you can just write down the prime factorization, and if it's a square root, you're looking for pairs or 2 of the same factor in order to simplify. Right? So either way that you approach that is perfectly fine. All right, so let's look at this one. So this one's going to be a cube root, right? And so with the, any other radical other than a square root, you're going to actually see a number for the index. And so here it's a 3. So 2 ways we can do this. We can either try to find the largest perfect cube that's a factor of 162, or we can write down the prime factorization of 162, and with the index being 3, we're not looking for 2 of the same factor, we're looking for 3 of the same factor, right? So either process that you want to use is perfectly fine. Again, the way that I like to do it is try to find the largest perfect cube that is a factor of 162. So 6 cubed is 216. That's too large. 5 cubed is 125. So 125 is a perfect cube, but it is not a factor of 162. Right. So then next, 4 cubed is 64. So I want to see is 64 a factor of 162, and it is not. 3 cubed is 27, and I want to see is 27 a factor of 162, and it is, right? We can rewrite 162 as 27 times 6, right? Well, I know the cube root of 27 is 3, right? Because 3 cubed is 27, so I will be able to simplify this part of it. So the cube root of 27 is 3, so we'll put the 3 directly in front of the radical symbol. And again, we still have this 6 underneath the cube root because, again, we don't know the cube root of 6. Now, the only way to factor 6 is 2 times 3, right? And so we don't know the cube root of either one of those. And so this is as simplified as we can get it, right? So the cube root of 162 simplifies down to 3 times the cube root of 6. And again, if you go about it the second way, again, you would start by factoring 162. Really, any way that you see, again, it's even. So, 2 is a factor, so we can write it as 2 times 81. And then if we look at 81, we can rewrite that as 9 times 9. Right, and if we look at 9, we can rewrite both of those 9s as 3 times 3. And so we end up with the cube root of 2 times, and then there's 3 times 3 times 3 times 3. And with the index being 3, we're looking for 3 of a kind, right? And so I'll circle 3 of those factors of 3, and so we can simplify that. So the cube root of 3 times 3 times 3 is 3. And so we'll put 3 in front of the radical, the cube root, and underneath the radical, we're still going to have 2 times this fourth 3. And we go ahead and multiply the 2 times 3 back to get 6. Right? So either one of those methods you use is perfectly fine. Now, what we're going to do now is look at being able to add or subtract radical expressions. All right, so this first example here, we have 5 times the square root of 2 minus 11 times the square root of 2. Now, the first step is if you can simplify the radicals, simplify those. Now, the square root of 2 is prime. We can't simplify the square root of 2 any farther. Now, in order to be able to add or subtract 2 radicals, 2 things have to happen. First, they have to be the same type of radical. They have to have the same index. So both of these are both square roots. They both have the same index 2. The other thing is the radicands have to be the same. The numbers underneath the radical have to be the same, right? And so here, they're both square roots, but they're also both the square root of the same number 2. So in order to add or subtract these, you don't do anything with the radical. It's going to stay the square root of 2, but you perform, whether it's addition or subtraction, you perform that between the coefficients, right? So we're going to have the square root of 2, and then we're going to say 5 minus 11 is negative 6. That's going to be the coefficient of our radical here, right? So I wrote down the square root of 2 first, and then I said 5 minus 11 is negative 6. So we have negative 6 times the square root of 2. All right, so let's look at this example. So here we have the square root of 45 plus 6 times the square root of 20 minus 7 times the square root of 5. So again, our first step, we're going to go through each one of these square roots and try to simplify. So if we look at the square root of 45, what's the largest perfect square that is a factor of 45, right? 36 is not a factor of 45. 25 is not a factor of 45. 16 is not a factor of 45. 9, which is 3 squared, is a factor of 45. So I'm going to rewrite 45 as 9 times 5. Right? And we'll be able to simplify that because we know the square root of 9 is 3. Right? So we'll do that in just a second. So then we move to our next radical. So again, we need to go ahead and write down plus 6, and then we'll have the square root. Now if we look at 20, the largest factor of 20 that we do know the square root of is going to be 4. Right? So I'm going to rewrite 20 as 4 times 5. But again, we can't forget it's 6 times the square root, and then rewrite 20 as 4 times 5. And now if we look at this last square root, it's the square root of 5. 5 is prime. So we can't simplify this square root any. So we'll just go ahead and write down minus 7 times the square root of 5. All right, so I'm going to go through and simplify. So on this first one, square root of 9 is 3. So we're going to have 3 times the square root of 5. And then plus, and so now we're going to simplify this square root. Now, make sure you have the 6, and now the square root of 4 is 2. Now, when we take the square root of 2, again, you multiply it to what's in front of the radical. So since we have this number 6, we need to say 6 times 2, and then we'll still have times the square root of 5, right? And so it's being multiplied to the coefficient of that radical. Now, I'm going to go ahead and multiply 6 times 2. Go ahead and do that multiplication. So 6 times 2 is 12. So I'm going to erase that and put 12. And then we have minus 7 square root of 5. So now we can combine any of these terms that have the same exact radical, right? Same exact index, same exact radicand. So all 3 of these are square roots, but they're also all square root of 5s, right? So we can combine these 3. And so the way that we do it, we're not going to change the square root. It's still going to be square root of 5, so I would go ahead and write that down. And we perform the addition and subtraction between their coefficients. So we would say 3 plus 12 is 15, minus 7 is 8. So it's going to be 8 square root of 5. All right, so I would write down the square root first and then perform the addition and subtraction between their coefficients. So if you were doing one of these and one of the terms had square root of 7 and another term had square root of 6, we couldn't actually combine those because the radicands would be different, right? We can only combine, add, or subtract when the radicals are exactly the same. Same index, same number underneath, same radicand.